a new method, and it evokes actually augmented matrices. But first we're going to start with something you're very familiar with, which is a system. And we're going to start with a system of 3 equations with 3 unknowns. So our first equation is x plus 2y plus 3z, and that equals 6. Our second equation is 2x plus 7y plus z, and that equals 13. And the third equation is x plus 4y minus 6z equals 1. And so we already know how to represent this as a matrix. Okay? So the matrix equation that would represent this situation would be, first we'll start off with our coefficient matrix. And our coefficient matrix is 1, 2, 3, 2, 7, 1, 1, 4, negative 6. And then we multiply that times our variable matrix. And in this case, our variables are x, y, and z. And we have that equal to our answer part, which is 6, 13, 1. Okay, so we represented this way. A times x, where A represents that coefficient matrix, x represents the variable matrix, equals b. And so one way we know to solve would be to do A inverse times b. So if we had our calculators, that would be a method that's not very difficult. It's pretty simple. Okay, so what if we didn't have our calculators? You can't do it. Okay, so if we didn't have our calculators, we might want to go back to that elimination method that we already know. But to combine that with matrices, what we're going to do is we're going to think about this matrix. 1, 0, 0, 0, 1, 0, 0, 0, 1. What is that? That identity. And what we want is, we want this to give us our x, our y, and our z. Okay, so we have a little dash line, and this is where we have our augmented matrix. This is what we want. We want our x, our y, and our z. Okay, so we're going to kind of combine this idea with what we have here. So what we want is we want this to turn into this. Because wouldn't that give us our x, our y, and our z? Okay, so this is interesting, and it makes a lot of sense, because we've already done this before with substitution and elimination. It's just a pretty way to organize it. Okay, so currently all this is equal to 6, 13, and 1. So we're going to use those algorithms that we learned with elimination so that we can find our x, our y, and our z. So what we want is for this row to end up looking like this. For this row to end up looking like this. For this row to end up looking like this. So that it will give us our x, our y, and our z. Okay. So we want to kind of turn these 3 into zeros. So let's start by getting rid of this 2. Okay? So what I'm going to do to eliminate this 2 is I'm going to take and multiply through this top equation by -2, and then we're going to add that to that row. We're multiplying the top equation through by -2, and we're adding it to this row. Okay, so that's gonna take us down to this. So the top row is not gonna change. The bottom row is not gonna change. What we're doing is changing the second row. So we're gonna take the top one, multiply through by -2, and add it to the bottom. So 1 times -2 is -2. -2 plus 2 is 0. 2 times -2 is -4. -4 plus 7 is 3. 3 times -2 is -6. -6 plus 1 is -5. 6 times -2 is -12. -12 plus 13 is 1. Okay? So now we want to turn this one into a 0. So if we just took that first row, I like it, and multiply through by -1, and add it to this row, it'll eliminate, it'll turn this into the 0. That's our next step. Okay. We're gonna take the first row, because we can't use the second one now because this is now 0. It won't make this go away. Okay? So we're going back to that top row and multiplying it by -1, so the top row is not gonna change. The second row is not gonna change. What we're changing is the third row. So if we multiply this through by -1 and add, what is 1 plus -1? 0. What is 4 plus -2? 2. What is 6 plus -3? What is 1 plus -6? -5. Okay. So really what we're trying to do, guys, is first we turned this coefficient into 0. Next we're turning this one into 0. Next we're gonna turn this one into 0. So if you look at it, it's kind of, we want a triangle of zeros right here. That's a good way to get started. So when we look at it, we want a triangle of zeros right here. Okay. So what do you think we can do now to eliminate this? Multiply which one?
-1.
Okay, so if we multiplied the first one by -1 and added it here, what would happen here? It would turn into a 1, and we want these three to be 0. Okay, so okay, if we divide this one by 3, would that help you to see how to eliminate that?
I don't know what like the order is.
Let's divide this one by 3. Let's see if that's helpful. That actually helps a lot, because what do we want this number to turn into? 1. And if we divide this by 3, it turns into 1.
Well, how about other numbers?
What about the other 3?
Yeah.
What about the other 3?
Yeah.
I'm only dividing this row by 3.
Oh.
We can do that.
Mm-hmm. Okay, guys, think about it. Is it fair to take an equation and divide everything in that equation by the same thing?
Yes.
Yes. That's what I just did. Okay. So that didn't get rid of what I wanted, but it did turn this into a 1. Okay, so now we got 1, a 0, 2, negative 9, negative 5. So now what can we do?
Oh, but then you get one. The top and the bottom. Divide by
This is
negative
now the
9.
1. Now I want to make this the 0. So how do I turn this into the 0? What if I take this row and multiply by negative 2? And we add it to this. Would that work?
Wait.
This is tricky, Miss Willoughby.
Why would you do it?
Well, then it would be 0 and
Why would you do
You could have
it?
solved it by now.
Alright, so here we go. 1, 2, 3. Alright, so we're building out that triangle, guys. We're getting it. We started here, 0, 0. Then we went here, now we're going here. We want this to turn into 0. So when we multiply this by negative 2, negative 2 times 0 plus 0 is still 0.
Oh.
Negative 2 times 1 plus 2 is 0. Alright, so when we multiply this by negative 2, we get positive 10 thirds. And this would be negative 27 thirds. Positive 10 thirds, negative 27 thirds. Gives me negative 17 thirds. Negative 2 thirds and negative 15 thirds is ooh. If I divide by negative 17 thirds, what does it turn this into? 1. What does it turn that into? 1. Woohoo! I got a row done.
Okay, once you find a row, can you just plug it in?
You have to keep going?
Do you really have to keep going?
Okay, so what we did, we're dividing this row by negative 17 thirds. So now I got 1, 1.
Okay, then we can go back and plug it in.
Now we can go back up, can't we?
Yeah.
What do I have to multiply this by?
Oh, I thought.
If I multiply this one by 5 thirds and add it to this, yep, it makes this go away. Okay, so we're multiplying this through by 5 thirds and adding it to this. So 5 thirds times 0 doesn't change that 1. 5 thirds times 1 is 5 thirds. Plus a negative 5 thirds is 0. 5 thirds times 1 is 5 thirds. Plus 1 third makes 6 thirds. And what is 6 thirds? 2. So now I know y is z is 1, y is 2. And we can work backwards to get the other 2. Can I do it in one step? Or do you want me to keep doing it separately? I'll do it separately.
I need 2 pages to set this one. This is all.
Alright, so if we want to get rid of the, let's just do it all at once. You guys can do this.
No.
You can follow this. Okay, so what we're going to do is we're going to take this and multiply by negative 3 and add it there. Then we're going to take this row and do what? Multiply by negative 2 and add it there. Can we do it at once?
You know which row to use.
Because negative 3 times 0 would just be 0. So you have to use the 1.
Okay, so when I multiply this by negative 2, what does that make happen here? Makes that turn into 0. And when I multiply this by -2, it adds a -4. Okay? Now, when I multiply this by 3, a -3, it's going to put a -3 there, and it's going to put a -3 here. Yep.
That's what we just did.
That's what we just did.
So -1, 2.
So x, y, z
Why don't we just use it?
is -1, 2, 1.
This is not practical.
I'm not gonna, yeah, I'm not gonna get.
Yeah, that's.
Hold on.
This is so impractical.
I feel like we just did like a bunch of random
Who
things.
made
and then
this?
got the answer.
Dude, this
Mostly
guy
like
just
a
this guy's spent his
lot.
whole life just to get make one of these.
Alright, so what's the other way to do this?
In the calculator, and I had it done like 5 minutes ago.
Yeah.
That takes 10 minutes.
It took 19 minutes. I'm
Yeah.
not even kidding.
Class almost over now, Miss Lily.
Alright, so your goal is
Do that.
to start here. We want this one to be a 1, and then we want zeros under it. Okay? And then the next thing, we want this one a 1 with zeros.
All the ones to be diagonal.
Yes. And then if it had 4, we would want zeros here.
I would just make it worse.
Okay, so we're working down our diagonal, and then we work back up.
Oh my god.
So we work down our diagonal to where it looks like a triangle here, guys.
Our homework just needs to be one problem, because one problem takes 30 minutes.
Every row you add is an extra
Okay.
10 minutes.
I think y'all got me today. Y'all never complained, and then I recorded your class.
Okay, most things like
It's not hard, it's just like
Okay.
so
It's kinda hard. I got
much.
lost.
What's the point?
I got lost and I don't understand. Jay, do you understand?
No, I don't.
We can just remember to
If
bring
No, I
Jay
just-
doesn't understand.
I understand it, it's just like, it's just,
No, I don't know.
You don't understand?
I just
You
feel like we
understand,
can-
you just don't know why.
It
Yeah.
reminds me
Yeah,
of-
I
What's
just
the
feel like
point
we
to
just
do
a
that?
bunch of random equations, like.
Okay,
multiply by
guys,
one.
do y'all remember? That's what you're doing when you use systems of equations.
Yeah.
That's exactly what you're doing when you use systems of equations. So whenever I gave you a 3x3, what you would do is you would group and you would group and you would eliminate one. And then you would group what's left and you would eliminate another. And then you would plug back in. That's exactly what we're doing. You were eliminating. You just didn't have the X, Y's, and Z's. And you can do more than one thing at once. Like that's in the wrong place. Okay, so if I had one like this, where I had, don't cry.
This is so funny.
I solved it.
I know I am.
This is why you don't want to cry. That's only the coefficients. Okay, so in one step, I could turn all of these into zeros. Okay, so if I multiplied through this top one by -2, and then I added it to this one, and this one, and this one, in one step, I could make all those 2's turn into zeros. Okay, so the top one wouldn't change. 1, 1, 3, 1.
I'm not confused.
Okay, but then we do -2 plus 2 is 0. -2 plus 2 is 0. -6 plus -1 is -7. -2, okay, 0. And then,
I'm just talking about it.
Oh no.
okay, then we can do it again. -2 plus 2 is 0. Negative 2 plus 3 is 1. Negative 2 is negative 6 plus, oh, I'm on this one. I got lost. Negative 6 plus 4 is negative 2, and then 0, and then 5. Negative 2 times negative 1 is positive 2, plus 3 is 5. Okay? And then negative 2 plus 2 is 0, and then negative 2 plus 3 is 1, and then negative 6 plus 4 is negative 2, and then negative 2 plus 4 is 2, and then 5. So see, you turn them all into it at once. And then you can just work your way through it like that.
It's not hard, it's just like, it's a lot.
Okay, so, guys, what we did on this one was we turned all these, and then next we want this one to turn into what? A 1.
So you do
And then what do we want these to turn into? 0. And then next we want this one to turn into what?
1.
1. And we want this one to be a 0. And then next one we want this to turn into a 1. And then we work our way back up. So you work your way down the triangle. Okay. You guys did not take a book on Friday. You have to today. Okay? So grab a book and I've got to write down which one you're picking up. Oh, this is bad.
Can we do it tomorrow?
Can I grab it tomorrow?
Okay, you don't have your homework's in that book. And y'all didn't take them Friday.
Is it online?
No, it's in that book.
Okay,
We made copies for 2 weeks.
I have 10:06.
Okay? Okay?
Did you have that?
Yeah.
Because you were talking about
Okay?
Did you?
129.
Did you really? Did you?
Okay?
Sorry.
That's annoying.
Most of
Yeah. 10:30.
Okay?
Yep.
Okay. 119. Alright.
10:28.
Alright, thank you. Alright.
Don't forget
Alright,
tomorrow.
thank you, Eric. Alright.
10:133.
133.
10:21.
Alright.
10, 110.
144.
Okay, got 110 and 144. Good. They're quick.
Miss Willoughby, are we
Yes.
keeping these at home or are we bringing them back?
Yes.
Okay,
At home.
thank you.
Oh, that's so cute.
Okay, did you come this morning?
Yeah, but I saw you in.
Yeah, but I was gonna leave them. They were fine without me.
I kept watching for you. Yeah, I came. I was like, oh,
You came in the door because I had my daughter sitting right there and she was supposed to let me know as soon as you walked
yeah, I
in.
came in the door.
They were just talking about companies. So they just said they'd meet Monday and
That's fine. Can we go over some of the questions across? Yes.
We'll do that first.
Is Olivia school in Florida?
No, she's not.
Well, you don't have like very good.
Oh, I do. Tell her story, and she thought she was lost.
They literally did like a hero card when I got there. It was, I wish they had thought. Like I had no hair, I was literally bald.
So I was on the video of this kid, his head is shaped like he gets like this weird ass haircut. And, like it's kind of like a mohawk where it falls like
Anybody else having
maybe. Like this guy like his hair is like coming up on the You have to see. Oops. Show it to you. I can't go to school anymore. Yeah.
How's it going? This weekend, like I was choosing to talk to random people. So they're like, I said hi, like their response was, I'm 16, and then they sent it again, and I was like,
Ashley Callahan,
I just said-
Lauren Cuddy, Sophia Bauer, Romy Sierra, Paige Whitmore, and Ethan Fowler.
like, I was just like, I'm 16, and it's like, but anyway, and I'm like, I said I'm 16. You seen Hayden's shoes?
Okay, I'm like, after that came out again, this is how she would treat me.
It looks good.
Oh, okay, you know what I mean. It's hideous.
I mean, he asked me where to get one. and
Oh, very nice.
That's how I'm supposed to.
I told him.
Oh,
yeah,
change
okay.
it? Yes. Are you, you told Jonah?
Oh.
That's like, I know, when she was like, you told her about that was I know, I told her that. And she's just like, well, you can take
I
it.
didn't even consent.
That wasn't me.
And then the future.
I've been like, I've been explaining this to you.
Oh, yeah, I didn't
Just
send it.
hasn't.
I don't have to follow the
Okay.
Yeah, I know.
Alright, I wanna see your review for your regular class, your regular math review. So you guys can pull that review out from your regular math class, it should be in the same notebook.
This will be, I wasn't here on Friday.
Okay. Do you have internet access?
Yeah.
Yeah? So did you check and see what you missed?
My mind was like on.
Yeah, it's gonna pay for your prom. I really suggest that we go.
No, that was like 7.
That's not good.
My mom was just like, cause like we have a camera that sits in the living room.
Okay, so I'm gonna make a note on here so I can see who's working in their regular math class also. So let me see these reviews. Support doesn't do you any good if you're not working in your regular class. That's part of it done. So do you have questions back?
I can't remember.
Depending on how much this is, I'll go and finish it.
Even though, even though,
It's just in the background.
Oh, y'all wanna get in front of
I would, I
I know.
I did yell at her. Because she was going to my shirt.
Hey, you want a credit card? Don't be stressed out.
I did. And he did it 3 times. And I looked at the, I was like, what are you expecting to read like 3 because I just read what was that? Did you read this? She said, no, but it's a good thing. I was like, this is exactly where I went. I was like, I looked at my eyes like that and I started looking.
What's that dude's name that's like hanging out with his I was texting Sarah because she found me one theater and she was like, I was like, I saw it on
I know you got it.
I was like, trees.
I know. So,
Alright.
so I was teaching Finnish, so no, I skipped it. I'm like, I want to shoot. So I can't.
Next, I'm just gonna go over and you have questions about ordinance.
Oh, this one, there's a second page that's the back.
I thought it was that it, but that's it.
No, it's just
Alright, you should, did you check our review? I posted that. Alright. Okay. Alright, I need all the phones to go away. So that I don't see them and then we don't have Tyler's today. Okay.
Thank you.
Hey guys, I'm gonna have one of those duh moments right now. Those of you that struggle at math, if you struggle and you don't practice, do not expect to pass, even if you have math class twice a day. So, if you struggle but all you do is watch, you don't get any better. If you struggle and you practice, you're gonna get better. You may not make a 95, but you're gonna get better and better and better. And it's gonna be okay. If I start checking your homework in your regular math class and I see you not working, I'm gonna talk to the guidance counselors and let them know that support's not doing any good because they're not doing anything on their own. And I will check in. I'll check in at every grading period. So I'll check in at the 4.5 weeks with all your teachers and at the 9 weeks, okay? Because this class is here for those that want to learn and that those that are trying, okay? And I want to help all of you that want to learn and all of you that are trying to be very successful. And if I can remove people that aren't going to do from the class, it'll give me a more opportunity to work with you that do. Okay? All right. I am ready to go over some of these. Madison had a question. Can you tell me which one you want to start with, sweetie?
Can we start with number 5, actually?
Number 5, yes.
Wait, do we have a quiz today?
We do. It's a short one. Okay. So here we have a power of I. And then we have some addition and subtraction. So when we have the powers of I to the first is I squared is -1. I cubed is -I. I to the fourth is 1. And I want you to write that at the top of your test. Write it there. So you don't have to think about it. You can just look at it. Okay? So when we look at this, this has an I cubed. Well, I cubed is -I. So instead of 90I cubed, we want to think about this as 90 times -I. Well, 90 times -I is just -90I. And this is a plus, so I'm not going to change any signs. Because this is a plus, I don't change any signs. Okay, and since it's just plus and minus, once I've switched this, I can just drop my parentheses and add my like terms. So this is -136 with 12 more makes -148. Now, on your test in your regular math class, we're not going to use numbers that big because we're not using calculators. So this -148 would go at the end and the -75 would come at the beginning. Because the real part has to come first, the imaginary part has to come second. Yes, Sarah?
75i, would you change it to a plus?
Right here.
Like if that was like 75.
If it was, you would just do that. So because there's not, if there was more than one thing back here, then yes, you would change. But because there's just one, you don't have to. Yes, Will.
What's the formula with the binomial and the trinomial? It's like a plus b.
Okay, so that's the factoring. So remember, our thing is SOAP. Same, opposite, always positive. You have to figure out what's being cubed and what's being cubed. So here A is being cubed, here B is being cubed. You square the first one, product of the two, square the last one. Now, it doesn't look much different when it's subtraction. The only thing that changes are the signs. So same, opposite, always positive. What's being cubed, square, product, square.
Do number 14.
Okay, so 14. This is a fourth power. So instead of breaking up into x and x, it has to break up into what?
X squared, X squared.
Yeah, because this is a 4. You have to do a 2 here and a 2 there. So you ask yourself, what do you multiply to get a positive 100 that we add to get a negative 29? Negative 4 and negative 25. Okay, so you always look at what's left and you ask yourself, will it factor any more? Okay, so does this factor more?
Yes.
Yeah, this is still a difference of cubes, so it factors to x plus 2 and x minus 2. What about this one? X plus 5, x minus 5. Okay, yes, Olivia.
Can you do number 10?
Number 10. Alright, what I would do first on number 10 is I would say 4 divides into 100 25 times. And I would start by simplifying it to this. Now you didn't have to do it that way, but that's the easiest way to do this problem. Then I would multiply the numerator and denominator by negative I. Negative I.
Because when I did it, I got 50.
Okay, I'll come look at your work in just a second. So a negative times a negative makes a positive. And then a positive I times a negative I makes a negative I squared. But what is I squared, guys? Negative 1. What happens to minus a negative? It becomes a positive. So the answer to this is just 25I.
I see what I did.
Okay.
Instead of, I did 4 times 4, but 8 instead of 16.
Okay, so we're going to go Christopher and then Madison and then Destiny.
Number 18.
Number 18.
I had a question about number 10.
Oh, the one we were just doing. Okay, yes ma'am.
Okay, so I multiplied by the reciprocal negative 4i
Okay,
and got something different.
okay. If you did negative 4i, in the numerator we ended up with positive 400i, and in the denominator you should have ended up with a negative 16i squared, which turns into a positive 16. Well, 400 does divide by 16. I probably wouldn't know that just by looking at it. But there are 4 quarters in every dollar. And if I had $4, that would be 4 times 4, 16 quarters. So So 400 does divide by 16 and gives us 25. So if you just stop right here, you can just divide that. Okay. Now, Christopher, you said which one? 18. Okay, so 18 is 4 terms. So when we have 4 terms, we're going to try that grouping where we put the first 2 together and see if they have anything in common, and then put the last 2 together. So if it has 4 terms, we're going to do grouping. So what do the first 2 have in common? An x cubed. And if we pull that out, what does it leave you? X squared minus 4. So over here we want an x squared minus 4. So what do we have to divide out? A negative 8. Because we want this to change to positive and this change to negative. So this gives me x squared minus 4, and this gives me x cubed minus 8. This is a difference of squares. And this one is a difference of cubes. So this one factors to x plus 2 times x minus 2. And this one, so same, opposite, always positive. So the cubed root, we square it, product of the 2, and square it. All right, I'm gonna let Madison, I'll come back to you.
1920.
Okay. All right, so we're gonna look at the graphs, and then we can come back and look at anything on the front page in just a second. All right, so the graphs are factoring. We have to factor first to get them in the right form. So if we look at 19, it's got 4 terms. So we're gonna break it up into 2 and 2. What do these first 2 terms have in common? An x squared. And we take that out, and we're left with x minus 5. And so we want an x minus 5 here, so what do we have to take out? A negative 4. So the x minus 5 is what they have in common, and then we group what's left.
Can't you factor that again?
Yes, ma'am. And that's the next thing we look for. Does this factor more? And it does. It factors to x plus 2 and x minus 2. So these are my factors. X minus 5, x plus 2, x minus 2. So if this is a factor, the opposite is an x-intercept. If this is a factor, the opposite is an x-intercept. The opposite is an x-intercept. So we take all our factors and do the opposite to get our x-intercepts. And then we plot those. We'll have one at 1, 2, 3, 4, 5. One at negative 2. One at positive 2. Okay, so we factor, and then we get our x-intercepts, and then we look at those ends. What's happening at the ends? So this is positive leading coefficient, and it has a degree of 3. What do the ends look like if it's an odd degree and a positive leading coefficient? It does. This one goes up, this one goes down. So it's like a line with a positive slope. It's just like a line with a positive slope. This end goes down, this end goes up. Okay, now if I look at my factors, all my factors, so that was 1 factor, 2 x-intercepts, 3, figure out what's going on with your ends. The last thing we have to do is decide what's happening at those roots. Does it pass? Does it bounce? What's the math word for bounce? or does it pass with an inflection? Okay, all of these are first powers. Understood 1, understood 1, understood 1. So all of these just pass. Pass, pass, pass. Yes, ma'am.
How do you know when it's tangent and then when it passed with an inflection?
Okay, it passes if the factor is to the first. It's tangent if the factor is to an even power, like 2. Usually 2 is what we see, but 4 or 6 or 8, any even power. And it passes with an inflection if it's an odd power greater than 1. 3 is what we usually see, but 5 or 7 or 9, any odd power greater than 1.
So if it's
6
6.
is even, even is tangent. Okay, so this one we'd have to factor out the GCF. Oh, I didn't finish. This one goes towards negative infinity and this one goes towards positive infinity. So we factor out the GCF, and what we have factors further. So we have an x cubed, an x plus 4, and an x minus 4, which gives me 0, 0, negative 4, 0, and positive 4, 0. So the factors lead me to the x-intercepts. So I plot those. So factor, x-intercepts, ends. Odd degree, positive leading coefficient, fall, rise. So factor, x-intercepts, ends. Now we gotta see what's happening at those roots. Is it passing, bouncing, or passing with inflection? So the negative 4 and the positive 4 were to an understood first power. Alright, so it's going to pass straight through. But the 0, 0 was to the third power. So it passes with an inflection. So you need to make it squiggly. And if you're not good at the squiggles, then we just put a little note right here and we tell our teacher this is an inflection. If you're not good making the squiggle. That help? Okay. Yes, ma'am.
I didn't understand like the negatives in number 3.
Okay. Let's go back and look at those from this end. Number 3. Okay. Alright, so there's a bunch of negatives in here.
So would you like just like
A negative under here. All this negative ever does is it turns into I. So this negative makes the I. The square root of 4 is a 2. So this doesn't change. This is going to stay negative. And the 7 stays under. So this negative makes the I.
So you wouldn't multiply the negative 15?
Nope, we're not multiplying because right now they're subtracted.
Oh, okay.
That's what this negative is, a subtraction.
Wait, can you just make that a positive and then like change the signs of it?
You can't make this a positive and go inside a radical.
Okay. Like what do you do with that negative?
It just stays right there. Yes, ma'am.
I have one more.
Okay.
Number 17.
Okay. Eric, did you need to see the rest of this? Did I go too fast?
Did you do any behaviors for number 24?
I did. I did them really fast. I'm sorry about that, bud. Okay. You said 17? Yeah. Okay. So 17 is, if you guys, I put this as a bonus on my last quiz. When I did my regular class, for my regular Algebra 2 class. When we have one that is both a difference of squares and a difference of cubes, You gotta do the squares first. So once we take the GCF out, we can see it's a difference of squares and a difference of cubes. So we have to do the difference of squares first. So that becomes x cubed plus 1 and x cubed minus 1. So this factors to x plus 1 square, product, square. This becomes x minus 1 square, product, square.
That's the whole answer?
Yeah, that's a long answer, isn't it? I'll box it with a highlighter. That's not a box. But that is the answer in my free form.
Does it matter which way you put it in first?
No, as long as you have all those factors in there, you're good. Yes, Cole.
So it's wrong if you don't take the GCF off first.
You have to take the GCF out first for it to be completely factored. Yes, sir. Yes, sir.
Can you do number 16?
I sure can. Okay. So, 16. Alright, 16 has a GCF, but it doesn't appear to help us very much. It's just x. If this were 12, it'd be better, but it's not. So we'll just take that plain old x out. Alright, now this one, I'll have to admit, is a harder one to factor without a calculator. I think the easiest way to factor this one without a calculator is to do the trial and error method, because this is a 3. The only way to get 3 is 3 times 1. And so now I want to end up with a negative 13. And so guys, if I put a negative 6 right here, that is negative 18. And a positive 5 right here, what is negative 18 and a positive 5?
90.
That's, if we multiply them, it gives us that 90 if we term split, and if we add them, it gives us that. So this is probably a little bit harder than I would put on a no calculator test. Because if you did the other method, when you multiplied them, you got 90. And I, right off the bat, don't think of 18 times 5 when I'm doing 90. No. Think of lots of different things, but not 18 times 5. And that's what I would have had to have thought of for number 16. Okay, do you guys have any other questions about your review? Okay, so we're going to take our little practice test in here today. I want you to do the very best you can. Those of you that would like to stay after school today, if you have your regular Algebra 2 test first or second period tomorrow, and you want to stay after school with me today to go over this, I'll be happy to stay until about 4:30. I can't. Or if you want to come in early tomorrow. Okay. Alright, go ahead and split your desk a little bit. I think your cover sheet will be fine. Do the best you can. I left a lot of space.
Luckily, I'm right.
guys, we're kind of pressed for time now. But I think what I did today was more important than this test. I would like you to do just the odds on the front page. Can you do that? So 1, 3, 5, and 7. I'll just do all the odds. All the odds. Because we are a little short on time, but what we did was more important. Just the odds. Just the odds on the whole thing.
Guys, that last one didn't run off well. I'm about to draw it on the board. Okay, if you do finish the odds, go back and do what you can on the evens. You might earn some bonus points.